Hello, everyone. In this video, we are going to discuss the cross product and its geometric interpretations. In a previous video, we discussed the cross product and how it is related to the angle between two vectors in 3D space. In this video, we will continue this discussion about the cross product and its geometric interpretations. Norm of a cross product and area. Consider vectors u and v, and theta as the angle between the two vectors. These vectors form the adjacent sides of a parallelogram. The base is the norm of u, while the height is computed using the sine of theta. Because the area of the parallelogram is the base times the height, and that the sine of theta is equal to the norm of the cross product all over the product of the norms, we get the result that the area is also the norm of the cross product of u and v. Hence, the norm of the cross product of two vectors is the area A of the parallelogram that has u and v as adjacent sides. Example. Find the area of the parallelogram that has adjacent sides u equals I plus 4j minus 7k and v equals 3I minus 6j plus 2k. Solution. The area of the parallelogram is the norm of the cross product of the two vectors. A. First, compute the cross product. Then, calculate the norm of the cross product. Therefore, the area of the parallelogram is equal to 44.8. If, for instance, we interchange vectors u and v, the cross product would be different because the cross product is not commutative. The negative sign indicates that the direction would be opposite. However, the norm would be the same, and consequently, the area would be the same. Scalar triple product and volume. The dot product of u and the cross product of v and w is called the scalar triple product. Its value is determined by the following determinant, which can be written as the following expansion. Because two row interchanges has no effect on the determinant, the following scalar triple products have the same values. Meanwhile, consider three vectors u, v, and w. These vectors form the adjacent sides of a parallelepiped. V and W form the base of the parallelepiped, whose area is the norm of the cross product of V and W. The cross product of V and W is this vector perpendicular to both V and W. Theta is the angle between U and the cross product of V and W. Let h be the height of the parallelepiped. Because the cosine of theta is h over the norm or length of u, then h is the norm of u times the cosine of theta. The volume of the parallelepiped is the area of the base times the height. We get the absolute value of cosine of theta in case theta might be greater than pi over 2, which would have made h negative. Moreover, recall that the cosine of the angle between two vectors is the dot product of two vectors divided by the product of their norms. Therefore, the volume of the parallelepiped is given by the absolute value of the scalar triple product, which can be computed using the determinant in the previous page. Example. Find the volume of the parallelepiped that has adjacent sides u equals I plus 4j minus 7k, v equals 3I minus 6j plus 2k, and w equals 2I minus 3k. Solution. First, calculate the scalar triple product using the determinant of a 3 by 3 matrix. The volume is the absolute value of the scalar triple product. Therefore, the volume of the parallelepiped is equal to 14. Note that any of the sides of parallelepiped can be used as u, v, and w, and the computed volume would be the same. Thank you for watching. Please like this video and subscribe to Professor Reginald's channel to get the latest updates.